Hello guys and welcome back to another video. Today we're going to be taking a look at this really nice integral, the integral of e to the x cos x. And this can be solved using a really neat trick that I realized while I was trying to solve it. So the first thing I want you to draw your attention to is the fact that this integral is made up of two separate functions. One function is e to the x, the other function is cosine of x. Therefore, we understand कि यहाँ हमने कहीं ना कहीं integration by parts apply करना होगा. So let's just set that up really quickly. Let me set my u as e to the x and let me set my dv as cos x, right? Let me differentiate u, meaning du, which remains e to the x, and let me integrate my dv. So we get v is equal to the integral of cos x is sin x. And for those who forgot the formula for integration by parts is the following. The integral of u dv is equal to uv minus the integral of v du. Alright, so now let's get started. The integral of e to the x cos x dx is equal to the following. uv, so this e to the x sine of x minus the integral of v du, so this, which is e to the x, again sine x dx. Okay, now we've made some progress, but we still have a little way to go. Why? Because look at this integral right here. This integral is again made up of two separate functions that we need to integrate separately. So that means we need to apply integration by parts again. And it may seem like we're gonna go in a loop, because if you integrate or differentiate sine x, you're gonna get cos x. So you might think we're going in a loop, but we're actually not, because there's a really neat trick at the end which really pulls everything together. So let me set up the second integration by parts, this time integrating e to the x sine x. So again, let me set my u as e to the x and let me set my dv as sine x. The derivative of e to the x is e to the x, and the integral of sine x is negative cosine x, right? And now let's do by parts again. So the integral of e to the x sine x is equal to uv, so negative e to the x cos x, minus the integral of v du, so negative e to the x cos x dx. All right, and now let's substitute some things. Let's say that I is equal to e to the I is equal to the integral of e to the x cos x, and j is equal to the integral of e to the x sine x, right? So let me write these two equations that we have and substitute them with I and j. So let me write the first equation that we have. So the integral of e to the x cos x, which as we defined earlier is I. So I is equal to e to the x sine x, e to the x sine x, minus the integral of e to the x sine x, which is j. So we write minus j. This is our first equation. Now let's write our second equation, which is the integral of e to the x sine x, which is j. Let's write this here. J is equal to negative e to the x cosine of x. Let's write the bracket. and the minus minus becomes a plus. The integral of e to the x cos x, which is again I. So plus I. This is our second equation. Okay. And what we needed to find in the original setup is basically I. So I'll substitute out j and we'll just solve for I. All right. So subbing in this j over here, we get I is equal to e to the x sine x minus brackets, sorry, negative e to the x cos x plus I. And now we just need to solve for I, which should be pretty straightforward. I is equal to e to the x sine x plus e to the x cos x minus I. So now we bring the negative I to the left hand side. We get 2I is equal to e to the x. Let's take e to the x common actually. So we get sine x plus cosine x. And we can divide everything by 2 to get rid of the coefficient of I. So we have I is equal to e to the x by 2 into sine x plus cosine x. So now we have I. And what was I again? I was the integral of e to the x cosine x, which we needed to find here. We need to find the integral of e to the x cosine x. Therefore, the integral, let me write this in orange. Hello, let me write it in orange. The integral of e to the x cosine x dx is equal to e to the x upon 2 into sine x plus cosine x. This is our final answer. I want you to take a good look at all of the working. This was a really fun question that I really enjoyed attempting, and I hope you had the same kind of experience. And I'll catch you in the next one. Allah Hafiz.